The Heliflow is most often used in Plan 21 and Plan 23 applications in accordance with API Standard 682 for pump seal coolers. API 682 requires that the heat exchanger have a positive vent and have thermal siphon capability, both of which the Heliflow heat exchanger can provide. Graham has performed extensive R&D testing of the Heliflow versus the single coil-in-can design in our laboratory, and the results show the Heliflow will provide superior performance in all applications. Please contact Graham to receive a copy of these results. The Heliflow is utilized as a vent condenser to reduce VOC emissions. By recovering the VOCs before they are emitted to atmosphere, a plant can meet stringent emissions regulations while recovering valuable process liquids for reuse. Most Heliflow vent condensers can be installed on existing tank vents or columns without the need for additional support. The Heliflow can be applied as a vent condenser in 3 different styles: the VCIM, the VCON, and the VCT. VCIN denotes Vent Condenser Inside Connection. VCIN is unique because there is no casing required. It is used when there is a connection large enough for the bundle to mount inside the flange or base plate. The vapors flowing out contact the cold Heliflow bundle, where it condenses and drains back into the tank. A baffle plate fixed to the bottom of the tube bundle maintains the spiral flow path and prevents bypassing of vapors. A drop tube can also be supplied in the outlet manifold to reflux condensate below the liquid level. The VCIN is typically used for new vessels or existing vessels with a connection large enough to accommodate a Heliflow bundle. This style is used outside of the connection. VCON is typically used on existing vessels and includes the casing. The VCON uses an existing flange, typically 2 to 3 inches in diameter. The vent condenser casing is fabricated with a mating connection to allow it to bolt directly to the tank or column. The advantage of the VCON is there is no additional support structure required, unlike other condenser technologies. The existing flange can typically support this vent condenser. VCT is used to condense the process vapor inside the tubes. This is most commonly used for corrosive fluid applications. In this design, the vapor is drawn into one manifold and is then directed through the tube coils. The non-condensable components are discharged through a connection at the top of the unit. A drain in the outlet manifold is used to pass the condensed liquid back into the tank. Tube side condensing of the process vapor also allows for subcooling of the condensate, which can be useful if the condensed fluid is needed in a chilled state for further processing. Any industrial gas that is supplied and stored in liquid form, such as nitrogen, hydrogen or carbon dioxide, can be vaporized in the Heliflow. The spring-like coil mitigates risks of damage from thermal shock or thermal fatigue because the coils can expand and contract as the temperature changes without stressing the shell or connections of the heat exchanger. A 3-pass tube side is often used in vaporizing applications to maximize heat transfer rates while maintaining a compact footprint. The Heliflow heat exchanger can also serve as a highly efficient instantaneous hot water heater. A sample cooler is used in refineries, chemical plants and other sites where a process sample is needed. Often the fluid to be sampled is operating at 600 degrees Fahrenheit or more and cannot be safely handled or tested at that temperature. The sample cooler operates in an intermittent service with a hot sample fluid passing through the coil as needed, and a cooling medium is constantly flowing on the shell side. Once the sample fluid hits the bundle, it cools to a temperature that can be handled. This type of application is thermally demanding for a traditional shell and tube heat exchanger, but not for the Heliflow heat exchanger.